Simultaneous equations by elimination 1. Simultaneous equations are equations where we find out what two letters are equal to. If they are different, then we add. Here's a normal linear equation. It's only got one letter to find out. For a simultaneous equation, there will be two letters to find out. Here we've been told that an apple plus a banana costs 100 pence. What does the apple cost and what does the banana cost? Well, there are lots of answers at work. The apple could be 80p and the banana 20p. Or the apple could be 30p and the banana 70p. So at the moment I don't know what the exact answer is. But if I also say that 2 apples and 3 bananas cost 240 pence, then I can say exactly what the apple is and exactly what the banana costs. The apple costs 60p and the banana costs 40p, and these are the only answers that work with both equations simultaneously. A plus b equals 10, a minus b is 4. What's a and b? The first thing I notice is that the plus b and the minus b are different, so I'm going to add both equations together to make them disappear. Add both equations together. A plus a is 2a, plus b plus minus b is nothing, and 10 plus 4 is 14. So I've made the b's disappear and I've just got 2 a's. Now, I don't want 2 a's, I want 1a, so I'm going to divide both sides by 2. 2a divided by 2 is 1a, 14 divided by 2 is 7, so a is 7. But I also want to know what b is as well. So I'm going to go back to the original formulas and write one of them down again. I've chosen the top one, but I could have chosen the bottom one if I wanted. A plus b is 10. Now I've just found out that a is 7, so I'm going to substitute that in. 7 plus b is 10. Now this is a normal equation, so I'm going to take away 7 from both sides. And I end up with b is 3. So my final answer is a is 7, b is 3. And that's the only answer that will work with both equations simultaneously. Three c plus 2d is 13. 2c minus 2d is 2. What's c and what's d? Well, the first thing I want to do is I want to get one letter by itself, so I need to make the other letter disappear. I notice that there's a plus 2d and a minus 2d. If I add both the equations together, the d's will disappear. So add the equations together. 3c plus 2c is 5c. 2d plus minus 2d disappears. 13 plus 2 is 15. So 5c equals 15. But I don't want 5c, I want 1c. So divide both sides by 5. And I end up with 1c is 3. So I found out what one of the letters is, but I also want to know what d is as well. So, go back to the original formulas and choose one. I've chosen the top one, but it doesn't matter. 3c plus 2d is 13. Now I know that c is 3, so I'm going to put that back in. 3 times 3 is 9. So 9 plus 2d is 13. I want to end up with d by itself, so take away 9 from both sides, and I end up with 2d equals 4. But I don't want 2d, I want 1d, so divide both sides by 2, and I end up with d is 2. C is 3, d is 2 is the answer. That's the only answer that will work in both equations simultaneously. 4e plus 3f is 13. 2e minus 3f is 11. What's e and what's f? Well, I need to make one of the letters disappear first of all. And I notice that there's a plus 3f and a minus 3f. They're different, so if I add the equations together, the f's will disappear. Add the equations together. 4e plus 2e is 6e. 3f plus minus 3f is nothing. 13 plus 11 is 24. So 6e equals 24. But I don't want 6e, I want 1e. Divide both sides by 6. 1e is 4. I also need to find out what f is. So choose one of the original equations and write it down again. E is 4, so 4 times 4 is 16. I want to end up with f by itself, so let's get rid of that 16, take away 16 from both sides. And I end up with 3f equals minus 3. But I want 1f, so I'm going to divide both sides by 3. And I end up with f equals minus 1. So E is 4, f is minus 1, is my final answer. It's the only set of values that will work in both equations simultaneously. Simultaneous equations are equations where we find out what two letters are equal to, instead of one letter. If they're different, then we add.